Okay, so is everyone who is in here intentionally coming to this talk? Because some people may have missed that there's some room changes happening. Okay, just letting you know, so if I see people start walking that way, I get it. Yeah, so I guess it's now 3 minutes in. I figured I would give people a little buffer for all the people who came in here thinking this was the Kafka talk. This is not the Kafka talk. If you're looking for the Kafka talk, that's in the room that I used to be in Skalkotas. So, yeah. Anyway, so yeah, hi, I'm Tiffany Jerningan. I am a developer advocate at VMware. This talk is not Kafka. It is cloud native security for the rest of us. If you still use like Twitter, I have my Twitter there. And then now there's just so many things. There's like Twitter, Mastodon, Blue Sky, blah, 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 LinkedIn, etc. I just gave up and I made a link tree. So everything's there, I guess. So yeah, thanks for coming, even though, yeah, hopefully everyone is still here on purpose. All right, so I'm just gonna dive directly into things from the get-go. So basically, less is more, which is kind of funny sounding because they feel like complete opposites. But basically, like the less that you have, the more secure that you can actually be. So for instance, you want to have less code. And where it's possible, try using things that are like managed services or existing security solutions that are already there instead of going and creating your own. Typically speaking, something that's already out there that has a bunch of people already working on it will probably have like more effort already put into it, more eyes on it, unless you decide that you're going to go and hire an entire team to do that yourself. So again, there'll be more engineers, there'll be more time. If something is out there that already works, might as well go with that. And maybe also if it's open source, then you can contribute to it as well, which is great. Also do things like make sure to give fewer permissions. For instance, basically only give the necessary permissions, and please avoid giving long-lived secrets, because if you accidentally like someone gets a hold of yours and say it lasts for an entire year, well, that's kind of a problem. And definitely make sure you don't do things like give someone root access. Bad things can happen, even if you're just someone's like on your machine and they just do the like rm-rf star. Oops. So also make sure to have fewer dependencies. Basically, this will help minimize the attack surface. So for instance, use something like a distro list image instead of going and using Ubuntu. Also, make sure that you keep up with like whatever the latest recommendations are. So for instance, Kubernetes, they have this checklist here that they update that you can just like check periodically to see what has changed. And apparently my clicker, I was trying to figure out why my clicker didn't work. It helps if you plug in the dongle. Anyway, technology. Yeah. Okay, so all right, there we go. So I grabbed this from the Kubernetes docs. These are the 4 C's of cloud native security. So it breaks it down into cloud, cluster, container, and code. And cloud could also be like colo or your corporate data center, for instance. And as a practitioner, basically you need to think about hardening your infrastructure at every single level. So the first thing I'm going to go into is platform, or basically like the cluster components. So unless you really need to run everything yourself, I suggest that you don't. You should instead use some sort of managed Kubernetes offering. There are quite a few of them out there. They've kind of been around for a little while now. These managed services take a lot of the workload for you. There's so much that you don't have to deal with setting up and making sure that like specific versions go together and different things just like work right. And also security and hardening is one of the primary value add-ons that you get when you get a cloud platform that is already doing all these stuff for you. So make sure to harden the control plane. So like only allow people to interact with the API server via the Kubernetes APIs, where they can't just like go and be like, here I'm a random person, I'm going to go SSH into the your node that you have your control plane running on. And also the less that you have running on your control plane servers, that's like fewer potential avenues for attackers to be able to like exploit to gain access to your cluster. Make sure that you use real TLS certs, such as something from Let's Encrypt, and please don't be lazy and just skip TLS verification. Like that little flag of like insecure, skip TLS verify, that's basically as good as just not having TLS at all. There is also this talk here called PKI, the wrong way, and it basically like demonstrates like how the end user ability to create like client certificates for MTLS can be leveraged to gain like complete control of an entire cluster. So like etcd basically goes and assumes that for anyone that can successfully authenticate with MTLS that they have proper access. To make sure to avoid this, you need to do things like restricting access to etcd, which there's docs that tell you how to do that. So another thing you need to do is to make sure to use pod security standards, or PSS. There's a bunch of different acronyms. Things have changed. Like it used to be PSP, which was like 121 and before that, and basically use these to prevent others from basically having access that they shouldn't have, such as root access to your nodes. And if you're using some sort of like cloud provider, there is a cloud metadata server. And this is where a bunch of the credentials and information is given into the virtual machine. You basically never want your pods to be able to have access to that. Lots of kind of scary vulnerabilities can happen. Like maybe if your attacker gets access to this metadata server, somebody could get credentials that are associated with like a VM service account, which is not good, obviously. And if a pod can have access to it, it can then go and get node credentials. And typically that has extra permissions that not just anyone has access to. And then perhaps they could do something like registering itself to the cluster during bootstrap. So a pod with some amount of work basically could pretend that it's a node and get workloads assigned to it, which is bad. Please make sure that you update Kubernetes. It's not good to be on many, many old versions ago. Kubernetes has basically been designed so that upgrades are pretty relatively seamless. And they have like long warnings, like a year in advance, basically being like, hey, this is going to be deprecated, like do something about this. We've gone a pretty far long way since OpenStack, back when you had to go and be like, hey, I need to create a new cluster, move all my stuff over, and then delete the old cluster. And I've just seen like way too many people using super old versions of Kubernetes because it's easier to do nothing. On most managed offerings though, like it's pretty simple to actually upgrade. A lot of them even have maybe like a button to click to do it, or you can even set it up to automatically do it for you. So basically, please try to stay up to date with like the newest patches, or like at least as close to the latest release as you can. And the more you update your cluster, the fewer CVEs that are already patched that you're going to have to potentially deal with. And like, if you're kind of scared of like, oh no, what's going to go wrong? Like, what's going to happen? Is my cluster going to blow up when I upgrade? It's more likely that you're going to end up having issues with things that are deprecated and dealing with the things that you haven't upgraded for a long time and trying to deal with that much later down the road. So as like a little example, this is for ingress. So say there's some API version that needs to be deprecated, so like the v1 beta 1 for networking. And so basically that was introduced in like 119. So at a certain point, you'll end up getting like all these lovely warnings at the bottom of your screen or whenever you're trying to use it that are like, hey, this is deprecated and it'll be removed in whatever version. So like this one it'll be removed in 1.22. Like you don't have to be immediately like, oh no, I need to go and fix this right now, but you do need to deal with it. And basically, there's this period of time in between where Kubernetes will support both of them. So you basically have about a year to go and actually make sure you deal with these upgrades. So you don't really have too many excuses. For your enjoyment, if you are not using a managed cluster and dealing with everything by yourself, this is basically all the stuff that you need to do to upgrade your cluster and in the specific order that you have to do it in. So you have to do things like updating the control plane, you have to upgrade your nodes, you have to upgrade clients such as kubectl, you have to adjust manifests and other resources based on the API changes that accompany the new Kubernetes version. So like as you can see, you really probably want to use a managed version of Kubernetes so you don't have to deal with all that yourself. All right, so isolating compute. So quotas and limits can be used so like noisy neighbors basically don't affect other workloads on the same host. They can also prevent an attacker from using your infrastructure for something like DDoS or crypto mining. You can also use things like taints and tolerations to schedule workloads away from each other, being like, hey, I don't want this orange workload running at the same nodes as this yellow workload, or whatever specific thing it is. You can also add another layer of security by using a sandbox container runtime, so something such as like gvisor, Kata, or Firecracker. And basically like adding this extra layer of compute isolation between the containerized workload and the underlying operating system kernel by just adding another layer of virtualization. So by default on Kubernetes, every single pod can talk to every other pod. If you're not okay with that, then you need to have network policies. And by default, Kubernetes also assumes that you trust the underlying network. So for example, that could be the network of your cloud provider. If you don't, which you may not, one way to address this is to set up a service mesh with full end-to-end encryption with, for example, like MTLS. Some people might say it's overkill, but all kind of just depends on what you need. You can also go the extra mile with it and use tools like Cilium for advanced network policies, such as being able to do like filtering on specific API routes. So for example, you could have like some front-end pod, for instance, and be like, hey, you can talk to V1 users, but you don't have, I'm not going to give you access to V1 billing, for instance, and using eBPF magic for that. So then there's secrets. So secrets can have different RBAC permissions. If you go hardcore, you could even go and encrypt them at rest, which Kubernetes supports. Basically, it'll encrypt resources that, like secrets, for instance, that are in etcd, and that prevents parties that gain access to your etcd backups from being able to view the content of those secrets. And that's another thing that is in the lovely Kubernetes docs. I don't know what I would do if Kubernetes had no docs. There's just so much stuff. And also, please don't directly put secret data in your config maps. Use actual secrets and have your config map reference them. Basically, it's just another way of trying to avoid accidentally committing up your secrets to GitHub and letting the whole world see it for a bit there, or however long. Even better, don't actually put stuff directly inside of secrets, but use something that will put them there for you. So like the whole point basically, again, is to avoid committing your secrets to GitHub. Like, you might find that obvious, but it's definitely a mistake that happens. I've definitely had just like, even doing a stream, I accidentally showed a password for like my Docker login and had to get things fixed for that. So stuff happens. Yeah, basically, unless you really need to, don't manage secrets yourself. You want to use some sort of like key management surface, such as like Hashi Corpus Vault, sealed secrets, Casmus, ops. There's just a bunch of like things here. I can share a link later for the slides where you can actually go and click through stuff. Basically, leverage the work that others have done for you to make your life easier and things also more secure. So people, which I assume is, at this stage in life, everyone here is a person. So you and your devs, and then robots, which I don't think we're there yet. I don't know. There's a bunch of AI talks. So like automated services and code running on your clusters, all these things need to be able to talk to the Kubernetes API so they can like do things like deploying stuff, scaling up and down, rolling out new versions, monitoring, viewing logs, etc. Basically all the things. But we don't want like our autoscaler doing something like, I don't know, mining Bitcoin, unless you did that on purpose. Or having like some sort of, your developers like running away with credit card information from a database. Or more realistically, maybe someone gets their laptop stolen and then someone tries to get credit card information from there. I mean, the only other time I've been in Athens, some jerkface stole my laptop at the Athens airport. So things happen. Yeah. Anyway, I was more careful this time around. But yeah, so that's why I'm going to, for the next big part, I'm going to be talking about user management and permissions. This section is like a, I guess, in a way, lower level version of another talk that I have done. that I basically go into a lot more depth into like the different ways of authentication and authorization. And then I actually have a demo for that, and I can share that later as well. You can probably just look up my name for Devoxx France. So yeah, basically we have good old separation between these two things. So if someone just says auth, and that's all they say, you kind of need to know which one. There's AUTHN, which is authentication, which is basically like, who are you? Then there's AuthZ, which is authorization, and that's the like, what are you allowed to do? Like, for instance, right now, am I allowed to just like run off the stage and pretend this is over? Like, I don't know. But yeah, so authentication. So Kubernetes is pretty flexible here. You can use TLS certs, maybe with your own CA or not. You can use OIDC tokens with basically any OIDC provider. So it could be something in-house like Dex or Keycloak, or maybe SaaS like Okta. And then you could in turn plug that in with, say if you're using some cloud provider with that cloud's IAM. So for instance, then you can basically map the cloud provider users to your Kubernetes users. Also try to remember to basically recall best practices. So like prefer using like short-lived credentials or certificates and stuff. Like for instance, use like an OAuth access token instead of giving like, here's my username and my password, because you probably change that less often. So there's like two sets of like, I guess, people or things that are involved here. So like I kind of mentioned earlier, so there's humans, everyone for now. So you would probably use things like TLS, OIDC, service accounts, etc. And robots tend to end up using service accounts. And so just like as like a little fun note, you don't go and do a thing like, hey, let me create a user. You give the, hey, I'm giving create pods or create X thing or do X thing permission to, like, I don't know, let's say I'm giving that permission to Matthias here. And as long as like someone shows up with like a valid cert or OIDC token for Matthias, then they can do creating pods or whatever else I gave permissions for. There is also the Spiffy project, which you can use for authenticating from one service to another. It's kind of an advanced use case, but these short or lived like identities basically help you move away from long-lived secrets. It's kind of an advanced use case more so, but like if you're interested in looking at it, you can go to spiffy.io. All right, so now to the other auth, so authZ, which is authorization. And that again is basically like, do you have the permission to do whatever it is that you are trying to do? The Kubernetes API server has several different authorization modes. So there's Node, ABAC, RBAC, and Webhook. The one that you probably are the most familiar with is RBAC. I guess the one question I never asked in the first place, who here has used Kubernetes? All right, most people in the room, cool. Who has heard of every single one of these things? A lot less, okay. All right, yeah. Who's heard of RBAC? Okay, cool. Yeah, so ABAC is attribute-based access control. Node is a special like authorization mode that grants permissions to kubelets based on the pods that they're scheduled to run on. There's webhook authorization, which allows you to use like custom authZ systems, such as plugging into your existing system that you already have. And well, as if anyone looked around the room, the obvious main one is RBAC. So I'm going to look at that next. So you probably all already know this then, or at least the majority of people who raised their hands. So the high level on Kubernetes is basically you go and define some sort of role. And that's basically a collection of like permissions, like things that can be done. So for instance, like can I view what's in the cluster? Can I list pods? Can I create deployments? Just like what is each specific thing that I have permissions to be able to do? And then you end up binding that role over to like some sort of like user or group or service account with either a role binding or a cluster role binding. So the role bindings, for instance, are specific to a namespace, and then the cluster role binding is for the entire cluster. So like, for instance, there's a default cluster role for view, which lets you view everything that is in a cluster. And if you don't create the role binding and associate that with like, say, a service account, it just kind of sits there, it exists, but you can't, it doesn't give you the permissions without like connecting them. So also make sure to audit your RBAC. So you may think that you gave someone access to just look at the pods in your cluster, but maybe you actually gave them permissions to delete everything in your cluster. And either someone, maybe they're not as familiar, they accidentally delete something, or maybe they hate you, so they just deleted everything. I don't know. So there's a bunch of different tools. So kubectl auth-cani-s list is built in by default into kubectl. All these other ones are other tools that they're little plugins that you would be able to add. And just like as a note, you can't actually take away permissions. So if you're like, here, I am giving you view access to the whole cluster, I can't be like, well, actually, I don't want you to see this deployment, or actually, I don't want you to see this. You basically need to just decide all the specific things that you want to give someone access to in the first place. And if you want, you could just give someone their own namespace, for instance, and let them do whatever in that namespace, and it doesn't affect your other ones. So permissions can be defined basically cluster-wide or in a specific namespace. So someone, for instance, could have access to do whatever they want in some namespace. Maybe you basically give them like cluster admin equivalent permissions in like the Bob namespace, and they can do whatever they want to that namespace, but they can't touch prod, for instance. So yeah, basically don't blanket give admin permissions. Really bad things can happen if you just give every single person in your organization or exterior like access to do whatever they want. That basically is like giving root access. And would you give every single person in this room root access to your laptop? Probably not. Hopefully not. Hopefully not. Anybody? Yeah. So basically namespaces make it easier to be lazy. So like if you're ever in doubt, and like someone needs access to a bunch of stuff, just like put that into their own namespace, give them access to that, just call it a day. They can do whatever. If they accidentally destroy everything, it's their namespace. So now I'm going to go into software supply chain, which has been a pretty popular topic, I feel, in the last like few years especially. And especially if you end up going to, who here has been to KubeCon? Wow. Okay. 2 people. Okay. All right. Yeah. So I noticed people talking a bunch about it like in the last like 2 years. The big things I keep hearing about lately are like software supply chain, WASM, and eBPF. But yeah, supply chain. So just as like a real non-tech real world like scenario to like relate it to. In 1982, this is a little morbid, I guess, but there was the Chicago Tylenol murders. Basically, they couldn't figure out like where in the supply chain that that something was being put into the tablets for the Tylenol. In the end, the solution was, here, let me put a seal on it, which is why now when you see medication, if there's no seal, you don't want it. So like, for instance, like for transport, like transportation is like avoiding person in the middle attack. You have a factory, which could basically be like your CI/CD pipeline. You can check it by like having this concept of like a secure factory. So for instance, in software, you could have like 2 brand new CI/CD pipelines and basically have them do the same build. If what comes out at the end is different, obviously there's something going on there. You can basically, yeah, check if, are those binaries, are they the same? They should be. Then there's like also things like threat modeling and identifying like who the like people are in the org. Like, is there a disgruntled employee or something like that? So if like, say there's some new vulnerability that gets disclosed, like how do you like, first of all, like determine, one, are you affected by this? And if you are, how do you go about like deciding about like deploying a fix or some sort of mitigation for it? Like, again, how do you know that you aren't just like running some sort of Bitcoin miner? Maybe you are. Basically, you can't be confident in the software that you're running unless you know where it came from and how it got there. So basically, do things like restricting the paths that code can like take, going from like the source code repo to getting to production. Like you need to check about all the steps along the way. Like make sure that you trace your deployed code back like along each step of the supply chain. So like, for instance, basically like you need to ask yourself a bunch of different questions. So like, for instance, there's a new change in the code. Like, does that change come from someone that you actually trust? One of the tools that you can use here to help is Sigstore's git sign to sign commits. So you're identifying like who you are with it. It's keyless, so you don't have to worry about GPG keys. And you can also use Sigstore's like cosign for assigning container images, but like being able to be like, hey, this is who I think it is that actually made this commit. Like, and then afterward, the next question is like, is the source code coming from your source repo? Making sure that you're actually pulling the source code from the place that you think you are pulling it from. Things like making sure that only authorized people can actually go and push to it. You don't want just any random person to be able to push over to your repo and then change things. And then when you are building your artifact, like, is that coming from a trusted source? Like, do you trust whatever it is? Maybe it's something you made, so you know you trust it. If it's from somewhere else, like, you need to have some way of knowing that you trust it. Is the build system itself trusted? Can you trust like where it's running and whatever it's running on as well? And then like once you end up actually building it, can you trust that like wherever you're pushing it to is something that you trust, and that only trusted people can go and push to wherever that location is? And ideally, the only thing that can actually go and push anything is your CI/CD pipeline, because you have this whole thing set up, and it's not just some random person being like, here, let me do this. So also, when you're dealing with like pushing things up, for instance, if you have dealt much with container images, there is vulnerability scanning for CVEs. Some of the registries, such as like Harbor, have image scanning built in. So you could be like, hey, I want to use Claire, or I want to use Trivy to do image scanning. You should also consider like an OPI like implementation for like policy enforcement. So for instance, one of the examples there is Gatekeeper. Sigstore also provides like an admission controller to assert image signatures and attestations as well. And then like another tool that can help like with the like along the whole pathway of supply chain is called InToto. Here are like some example like threat model things that basically have happened at some point in time, and like how to go about it. So like the first question is like, who is your attacker? That's like an important question there. So like say someone is making changes to your code that you depend on, and then that causes things to break. So maybe like it's some sort of like malicious, or maybe not, maintainer of some sort of package that your code depends on, and they made some sort of change, or they delete it, and then suddenly everything you have is now broken because you depended on that. So one way to go about handling that is to have immutable dependencies. Like basically, are you vendoring your dependencies, or are you effectively giving some other entity like arbitrary write permissions to your code in a way? Because if you're pulling in it and it can just change, it's changing what you're giving out there as well. There's also the SolarWinds hack. So that was an attack on actual build infrastructure. So basically, there was the code that was produced by the build server had some sort of malicious code that was injected into it, and that allowed external access. So other people that weren't part of this company now had access to this build server. And they were able to inject like malicious code and sign it with SolarWinds signing key, which is not so good. Like one way to go about handling this is to have ephemeral builds. So basically, don't have a dedicated machine that someone can hack into. Like, have a build system that spins up on demand. Like, if it doesn't exist, it can't be hacked. It's just, like, it can't happen. So have, like, hermetic builds. Like, also, like, with that basically is where you don't have access from, like, the outside world to be able to do something into it. So that makes it also easier there. Basically, in that case, it can only do things with the code that's provided to it. You can't like do things with network requests. Basically, it's like completely air-gapped if you do it that way. And also make sure that your builds are reproducible. Like being able to do the same thing over and over and over again, and it's exactly the same, is super important. So just wanted to go through a few more things that aren't related to the things that I've already talked about. So there's like a few additional components. I mean, there's so many additional components. Who here has seen the CNCF landscape? Okay, if you're bored, go look at it. It's a lot. There's just so many things on there. Like Josh Long has described it as like fractals. It's just, it's intense. So there's a lot more than just this. This is just a little bit. But like, long story short, if you just spin up a cluster by clicking around on some sort of like web console, or do something with like, I don't know, EKS cuddle create cluster, the result is basically far from being production ready. Actually, Matthias and I did a talk at KubeCon 2 weeks ago about like the gaps between here is my vanilla Kubernetes cluster and getting to production readiness. So for instance, backing up your cluster can be very important. Things happen. You can use tools such as Valero, so it will back up like the workloads that you have running on your cluster as well as the persistent volumes. You could decide, hey, I want to just copy everything I have running this one cluster over to another cluster, or, oh no, something went wrong at 2 a.m. and I can't figure out what's wrong, I can't fix it, but hey, I have this backup from like 3 hours prior, let me just revert to that. Another big thing is observability. So metrics can basically help you determine if something is going unexpectedly and also be there to help you try to solve it. Because if you don't have data of seeing what is changing or staying the same, how do you, unless it's like super obvious that something's broken, how do you really know? Also, good logging. Good logging is basically very indispensable for good security because we want to be able to do auditing for like who is doing what. We want to be able to see things like what user is doing X thing, like what is there some sort of privilege change? Did this person suddenly get like cluster admin access and I didn't do that on purpose? Like that's a problem. Want to be able to see things like privilege creation, security events, interruptions to logging, just a bunch of different things there. And like also you can't forget about your code. There is this thing called OWASP for source code analysis. So you can just go like OWASP.org, but like it's this entire pathway starting literally from the code that you're writing through like all the building, the pushing it somewhere, the deploying, and it just like being out there and running. Like you have to worry about security the entire way. You can't just forget about one little step. And here are some resources. So as I mentioned, the CNCF landscape. And then there's some docs on the Kubernetes docs for like security and cluster administration. There's also a link there for SigStore. But yeah, thanks. And thanks for sticking around and coming, even though the rooms are, yeah. This room is cool. I like the red in the other room.